Hi guys, now here we have more on complex numbers. We're going to do a little exercise that shows how to multiply and add and subtract complex numbers, which is fairly straightforward probably. We're also going to take the root of a complex number and we are going to look at dividing as well. So let's go. This is the task. I'm just going to go through the task and we'll see what happens. We need to find a complex number z that satisfies 4 take 2i times z equals 3z plus 2 take 5i. So 4 take 2i multiplied by z equals 3z plus 2 take 5i. So there you have a mix of z. Z is a complex number already. Z is a plus bi. And there's another complex number and there's another complex number there. A real part, real, imaginary, etc. So the way to tackle these problems normally is to say, okay, if z is a complex number, let's assume it is a plus bi. And let's do the multiplication. 4 take 2i multiplied by a plus bi is going to be the same as 3 times a plus bi plus 2 take 5i. Now, here's the multiplication of two complex numbers. So we can use FOIL on that. It's just expanding brackets. 4 times a is 4a, 4 times bi is 4bi, negative 2i times a is negative 2ai, and negative 2i times bi is negative 2bi squared. But remember that I squared is 1, sorry, negative 1 of course, negative 1. I squared is negative 1, so negative 2i times bi makes a positive 2b. Right? The other hand side is 3a plus 3bi, add 2 take 5i. Now it's a matter of collecting the real parts and the imaginary parts, so they belong together. So on the left hand side we've got 4a and 2b are the real parts. The imaginary parts are negative 2a and 4b. They are multiplied with I. On the right hand side I've got my 3a plus 2 as a real part. And the imaginary parts are negative 5, 3b take 5. And there's no a in that bit. Now, so now I have two complex numbers, real part, imaginary part, and on the right hand side there's another complex number with the real part and the imaginary part. If these are the same, then the real parts need to be the same and the imaginary parts need to be the same. So I can make a split here. I can look at the real parts and say 4a plus 2b needs to be 3a plus 2. Now if I write that out, I get a plus 2b equals 2. Now, also the imaginary parts need to be the same. So the negative 2a plus 4b needs to be the same as 3b take 5. Now if I write that, then I get negative 2a plus b equals negative 5. So two equations, 1 and 2, with two unknowns, a and b. From the first one I can immediately see that a is 2 take 2b. Okay, So I can use this result and plug it into the second one for A, because A is the same as 2 take 2B. So I'm going to do that. So negative 2 times 2 take 2B plus B is negative 5. If I work that out, it says negative 4 plus 4B plus B is negative 5, which means that 5B is negative 1, B is negative 1 over 5. I can use that result to plug in there, plug it in back here to find A. So A is 2 take 2 times negative 1 over 5. That's 10 over 5 plus 2 over 5, 12 over 5. Now we started off by saying that Z is A plus BI, to be 12 over 5 take 1 over 5i. This is the complex number that satisfies the equation. So there you have multiplying, adding and subtracting all in one big example, really, which is very much similar to ordinary expanding and collecting like terms and expanding brackets and that sort of thing.